In 1966, the term a recommended national program in weather modification refers to a significant policy report, often called the Newell Report, that outlined a strategic framework for the United States to systematically study and control weather phenomena. While NASA was not the lead agency for weather modification, that role primarily belonged to the National Science Foundation, NSF, and later the Bureau of Reclamation. NASA was a critical partner providing the high-altitude technology and satellite data necessary to monitor atmospheric changes. The 1966 Newell Report, ICAS Report 10A, the report, titled A Recommended National Program in Weather Modification, was submitted by Homer E. Newell, NASA's Associate Administrator for Space Science and Applications, to the Interdepartmental Committee for Atmospheric Sciences, ICAS. Key objectives of the proposed 1966 program included scientific monitoring, establishing a national network of monitoring stations to distinguish between natural weather variations and human-induced effects, cloud seeding research, evaluating the effectiveness of injecting silver iodide or dry ice into clouds to increase precipitation or suppress hail and lightning, hurricane suppression, exploring methods to reduce the intensity of severe storms through thermal or chemical intervention. NASA's specific role, providing satellite platforms like the ATSI launched in late 1966 to capture real-time data for post-experiment analysis of seeding trials. Interagency Cooperation in 1966. The program was a collaborative effort involving several federal departments, with NASA providing technical support rather than direct field operations. American Meteorological Society. American Meteorological Society, NSF, served as the primary coordinator for basic research and annual reporting to Congress. Department of the Interior managed Project Skywater via the Bureau of Reclamation to increase water resources in the West. Department of Commerce, Weather Bureau, focused on forecasting and operational monitoring. NASA allocated approximately $69,000 for weather modification-related projects in fiscal year 1966, focusing on satellite applications and atmospheric research. In the 1960s, NASA's satellite missions shifted from simple cloud cover imaging to providing the precise atmospheric data needed for weather modification research. These missions allowed scientists to observe the before and after of experimental seeding and track the internal structure of storms. 1. TIROS series, television infrared observation satellites. Launched starting in 1960, the TIROS satellites were the first to prove that cloud formations could be monitored from space. Scientific contribution. They documented for the first time that large storms have vortex, pinwheel patterns. Weather modification link. By 1966, the operational TIROS satellites provided the big picture data used to identify optimal storm systems for modification experiments. 2. Nimbus program, second-generation research. Launched in 1964, the Nimbus satellites were more advanced, three-axis stabilized platforms designed specifically for atmospheric research. Nimbus 2, launched May 1966. This satellite was critical during the year of the Newell Report. It carried the high-resolution infrared radiometer, HRIR, which allowed for nighttime imaging of clouds and storm intensity. Atmospheric sounding. Later Nimbus missions, starting with Nimbus 3 in 1969, were the first to sound the atmosphere, measuring temperature and humidity at different altitudes, data essential for predicting how a cloud would react to seeding. 3. ATS-1, Applications Technology Satellite. Launched in December 1966, ATS-1 was a game-changer because it was the first weather satellite in geostationary orbit. Continuous monitoring. Unlike earlier satellites that only passed over a storm every few hours, ATS-1 stayed fixed over the same spot. It could take a new picture every 20 minutes. Weather in motion. This allowed scientists to create the first time-lapse movies of developing hurricanes and storms, providing real-time feedback for field experiments. Summary of missions. Supporting 1966 goals. Mission launch date. Key contribution to weather modification research. TIROS 10. July 1965, provided the primary global cloud cover mapping used in 1966. Nimbus 2, May 1966, first to provide high-res nighttime infrared data of storm heat. ATS-1, DECD 1966, first to offer continuous, near real-time tracking of storm growth. Project Storm Fury 1962 to 1983 was an ambitious joint initiative between the U.S. Navy and the Department of Commerce, later NOAA, to weaken hurricanes by seeding them with silver iodide. While NASA didn't run the seeding missions, its satellite technology provided the high-altitude monitoring that was impossible from the aircraft flying inside the storms. The seeding hypothesis. The Storm Fury hypothesis was based on a simple physics analogy. Like an ice skater slowing their spin by extending their arms, scientists believed they could slow a hurricane by forcing its arms, the eye wall, to move outward. The method: aircraft would fly into the clouds just outside the hurricane's eye and drop silver iodide. The expected goal: this would cause supercooled water to freeze, releasing latent heat and triggering the formation of a new, larger eye wall. The result: this larger ring of wind would compete with the original inner eye wall, eventually causing it to collapse and reducing the storm's peak wind speeds. Experimental successes and NASA's data project. Storm Fury achieved its most successful results during the late 1960s, coinciding with NASA's peak satellite development. Hurricane Debby, 1969. This was the project's landmark success. After being seeded on 2 separate days, wind speeds dropped by 31% and 15% respectively. Satellite verification. Using NASA's ATS-1 and Nimbus satellites, researchers could track the storm's overall symmetry and cloud-top temperatures during these seeding runs. This provided global context that helped researchers distinguish between human-induced changes and natural storm migration. Why it ultimately failed. Despite initial optimism, later research using more advanced data, much of it from NASA and NOAA satellite archives, revealed 2 fatal flaws that led to the program's cancellation in 1983. Lack of supercooled water. Scientists discovered that hurricanes naturally contain far more ice and far less supercooled water than they originally thought. Without enough liquid water to freeze, silver iodide seeding has no effect. Natural eye wall replacement. Satellites observed that even unseeded hurricanes naturally go through eye wall replacement cycles, where an outer eye wall forms and chokes off the inner one, exactly what Storm Fury was trying to do artificially. The successes of the 1960s, like Hurricane Debby, are now largely viewed by the National Hurricane Center as natural occurrences that happened to coincide with seeding efforts.